Hello everyone, friends. As always, you're watching the new Generation Airships project. You've often asked us questions and shown interest in how our stratospheric probe launches are conducted. And today, together with Dmitry Sergeyevich Khmel and Bauman University, we are here near Kirov, to show you the process of launching our next long-duration drifting stratospheric probe. As you may remember, our previous launch was carried out from the city of Kirov. At that time, our primary goal was to make a full round-the-world journey around the North Pole. Now, since the Great Northern Vortex has dissipated, our current objective is to learn how to navigate within the existing active air currents by changing our altitude, to fix and hold the device over a specifically designated area. Right now, the team is carrying out the final preparations, including the final weighing. In just a very few minutes, we will indeed begin the launch, and we'll definitely show you how the whole process goes.
This launch is taking place outdoors, in the open air. We are using a launch system developed by MVTU, which allows us to fill the aerostat in field conditions. After that, with permission, we launch it and it begins its journey, which will last several days. As a result, we will test the aerostat's ability to balance at different altitudes for hovering. This is so that it doesn't fly too far away and can perform many functions in the future once this technology is fully developed. We plan to develop these advanced aerostats not only for long-distance flights, but also so that they can effectively hover over the specific regions we need and meticulously monitor certain designated areas. This is quite feasible. Even without the use of engines, aerostats are already being used around the world, and they can effectively hover over fairly limited areas. However, this doesn't always happen in practice. It occurs when the appropriate atmospheric conditions come together. Right now, we are actively working on a new technology with two distinct envelopes. This allows us to better tune each envelope for its own cruising altitude. And in the future, we will share more details once we have developed this technology. Essentially, the first step is testing the envelopes. The system for changing buoyancy itself will be developed in the future. Right now, we are testing a dual envelope balancing system. That is, one envelope balances the aerostat at one altitude. The second, under specific heating conditions, carefully balances it at its maximum operational altitude. This allows the aerostat to effectively change its altitude within a fairly wide and adaptable range. It's possible to maintain this range quite precisely.
Friends, as you can see, we've now almost completely filled the envelope with helium. We have just a few minutes left before our launch. Right now, the team is conducting final checks of all systems. We'll be connecting the onboard computer and the ballast system, and in just a few minutes, we'll launch our device.
3, 2, 1, and now we are ready to launch. Let's go!
That's it, my dear friends. We are taking off now. We are balancing the computer. This is truly awesome, guys. Guys, our launch has just happened. We traveled a significant distance of 200 kilometers to carefully show and film the compelling material that we are eager to share with you. So be sure to like, leave a comment, and share the video. And there will be more launches like this.